What's up, YouTube? Thomas Lackey here. I wanted to talk a little bit about insulin, how exercise lowers blood glucose, how insulin lowers blood glucose, diabetes, people who are insulin resistant. So the way I'm going to start this is just kind of by starting from the top of how insulin actually works. When you eat a high carbohydrate meal, carbohydrates are going to get digested, absorbed, and released into the bloodstream, and this is going to increase blood glucose. Your pancreatic beta cells are going to secrete insulin in response to this elevated blood glucose, and your skeletal muscle is responsible for about 80% of glucose clearance from the blood. Now, insulin is going to bind to an insulin receptor. Let's just pretend it's on a muscle cell for this example. And upon binding, it's going to stimulate the PI3K AKT pathway. Now, this pathway, the downstream effects of this, it's a phosphorylation cascade reaction. The downstream effects is going to phosphorylate a protein called TBC1D1, and this protein is going to travel down to the storage compartment of the cell, and it's going to bind with Reb GTP or GTP, I believe. I'll have to look this up later. It's Reb GTP or GDP, but it's going to bind to Reb, and upon binding, it's going to release a protein called GLUT4. GLUT4 is going to translocate or move to the plasma membrane, and it's going to fuse with the plasma membrane. And that's kind of the whole goal of insulin, is to get GLUT4 protein to the plasma membrane, because once GLUT4 is inserted, it is going to act as a glucose channel, and it's going to allow glucose to enter the cell from the blood. This is going to lower blood glucose, and it's going to provide the cell with glucose. And the cell at this point can either synthesize glycogen, or it can break down the glucose through glycolysis. Now, exercise also stimulates GLUT4 translocation, or GLUT4 inserting itself into the plasma membrane, but it's through a different pathway. It's the AMPK pathway, but it's going to cause the same thing: phosphorylation of the TBC1D1. TBC1D1 is going to interact with Reb. This is going to release GLUT4. GLUT4 is going to move to the plasma membrane, and it's going to begin sucking up glucose. Now, when you contract your muscles, the sarcoplasmic reticulum, it's an organelle in the cell, it's going to release calcium, and calcium has also been shown to amplify phosphorylation of TBC1D1. So really, I mean, this is, you don't need insulin to cause GLUT4 translocation if you're just exercising. So exercising is an amazing tool, especially if you're diabetic or have insulin resistance, because not only will it lower blood glucose in the short term by causing that GLUT4 translocation, but in the long term, it's actually going to sensitize your insulin receptors. So that way, when you do eat a high carbohydrate meal and insulin is released, insulin's going to be more effective, and you're not going to need as much insulin to have the same amount of effects. It's going to increase binding, the signaling. So regular exercise is going to resensitize your insulin receptors and make you more sensitive to insulin. What else do I want to talk about with insulin? Insulin is also anabolic directly. A lot of people will say, no, insulin is not anabolic. Insulin will cause amino acid uptake, glucose uptake into the cell, which then can promote anabolism. But however, insulin is not directly anabolic, but that isn't true. Insulin is anabolic because it stimulates the PI3K AKT pathway, and this pathway will stimulate mTOR. mTOR is a protein in the cell that integrates a bunch of anabolic signals, and it controls the rate of growth for that cell. When mTOR is stimulated, it's going to increase muscle protein synthesis. It's going to tell the cell to start growing. Insulin, by stimulating that PI3K AKT pathway, is going to stimulate mTOR, which will increase muscle protein synthesis. There's a little caveat here, because although insulin turns on the machinery of your cell to start growing, if all the supplies aren't there, your cell can't grow. And the supplies your body needs to grow new muscle tissue is amino acids. And it needs all 20 amino acids. Specifically, it needs the 9 essential amino acids, and from those 9 essential amino acids, it can then make all the other amino acids that it needs. But we need those 9 essential amino acids to be the building blocks of this new protein structure that we're building. So you can kind of think of it like insulin basically turns on your printer. So your printer is now able to start printing pages, but if you don't have the ink, if you don't have the paper in the printer, which is, in this scenario, the amino acids, you can't print anything. So it's cool that you turn the printer on, but the printer is just going to sit there turned on, and eventually it's just going to idle and turn off if it doesn't have any supplies. Hopefully this was kind of helpful. Insulin is awesome. Oh, I can get into one more topic with insulin, I think. Well, I can't. Insulin also causes vasodilation in the microvasculature of muscle tissue. So basically, it's going to dilate or expand small blood vessels and capillaries inside of muscle tissue. And this is going to increase blood flow. By increasing blood flow throughout muscle tissue, this is going to increase glucose uptake into the cell. So you can think insulin causes the GLUT4 translocation that we talked about earlier, which makes the cell permeable to glucose, but it also makes blood just travel faster through the muscle. So you can just think, more glucose is traveling quicker, so it's more likely to go into cells, especially if they're permeable. So this response, this isn't like a normal response, like a normal healthy adult. You have these, you have the vasodilation from insulin. But as we age, or if you're diabetic or insulin resistant, you're not going to have this dilation effect, this vasodilation. And they've actually done some studies where they have kind of mimicked this, I should kind of back up and explain the pathway a little bit. The way it causes vasodilation is through that same PI3K AKT pathway. Insulin is going to bind with the cells that are in your vasculature, that line your capillaries, your vasculature. Upon binding, it's going to stimulate this PI3K AKT pathway, and this is going to stimulate nitric oxide production. And nitric oxide causes vasodilation. So that's the mechanism behind it. As I was saying, if you are older or you're insulin resistant or you're overweight, diabetic, you're not going to have this response. And they've done some studies that show that they've done, some insulin clamp studies, they've done nitric oxide inhibitors. They basically mimicked this, and they looked at if we do not have this vasodilation effect in muscle tissue, how much glucose is taken up by muscle tissue just off of the GLUT4 translocation. And they found that around 50 to 60% of the glucose uptake was from this vasodilation effect. Insulin is an awesome subject. I really have been thinking about insulin a lot, especially because I've been writing this ebook about protein and stimulating muscle protein synthesis. And, I think just learning about the AKT pathway and stimulating mTOR it's been one of the cooler things I think I've been looking at lately. But anyway, hopefully someone learned something. Hopefully this was valuable. Again, my name's Thomas Lackey. I am a member of Troponin Nutrition. I work under Justin Harris. You can find me at teamtroponin.com, troponinnutrition.com. I've written content on musclementor.net, and you can check out my Instagram on Lackey, LACKIE _nutrition. Tropo gang, out.